Hey there, and welcome to The Explainer. Today, we're diving deep into reactive programming in Java. Now, this isn't just some new trend. It's a huge shift in how we build software, especially for the crazy demands of the modern internet. It's all about moving our apps from the brink of total overload to systems that can handle a constant, overflow of data and requests without breaking a sweat.
So here's how we're going to break it down. We'll start by looking at why our old ways of coding are kind of hitting a wall. Then we'll get into the new reactive paradigm itself, understand what it means to think in data streams, and see where it's being put to work in the real world. And finally, we'll take a peek at what's next. All right, let's set the scene. Why did we even need a whole new way to program? Well, it's because our digital world hit a breaking point. We reached a scale where the traditional, tried-and-true methods of building applications just couldn't keep up anymore.
I mean, just think about it. Modern apps aren't just for a few hundred people. We expect them to handle millions of users all at once, crunch through petabytes of data, and give us an answer in milliseconds. And that's not the exception, that's the baseline. Whether it's an e-commerce site or your social media feed, that's the expectation. And the traditional ways of programming? They just weren't built for that kind of pressure.
You see, the traditional model is like a grocery store where every single customer gets their own personal cashier. If your cashier has to wait for a price check, you wait, and that cashier can't help anyone else. In code, this means every request grabs a computing thread and holds it hostage, even if it's just waiting for a database to respond. It's a huge waste of resources. But the reactive model? It's completely different. It's like having a few super efficient cashiers who can juggle dozens of orders at once. They never sit idle, so they can serve way more people with a lot less effort.
So, to handle these massive new challenges, a new paradigm had to emerge. It's a fundamentally better way to build responsive, efficient systems. This is where we get into reactive programming.
At its heart, reactive programming is all about building applications that react to stuff as it happens. So instead of constantly asking, hey, is the data here yet? You build a system that just listens for streams of events, things like user clicks, data from a sensor, or stock market updates, and you process them as they arrive. And you do all this without ever blocking the rest of the system. It's a big shift from commanding your code to just reacting.
And this isn't just some vague idea either. It was all laid out back in 2014 in what's called the Reactive Manifesto. This thing gives us a blueprint for building solid, modern apps based on 4 key ideas. They have to be responsive, so users get fast feedback. They need to be resilient, meaning they don't fall over if something breaks. They've got to be elastic, scaling up or down to meet demand. And the glue that holds it all together. They are message-driven, using asynchronous messages to keep everything decoupled and running smoothly.
So, okay, how does this all actually work? To really get reactive programming, you have to start thinking in data streams. So let's break down the concepts that make it all tick.
Everything really boils down to 2 key players, the observable and the subscriber. Think of the observable as the source. It's like a news ticker or a Twitter feed that's constantly pushing out new events over time. And then you have the subscriber. That's the listener. It signs up to that observable and is just ready to react whenever a new piece of data comes its way. The key here is that it's a push model, not a pull model. The data comes to you.
And the journey for each bit of data is pretty cool. An event gets emitted and it flows into this pipeline. Along the way, different operators can transform it. Maybe you filter out some events, combine different streams, or change the data's format. And then, once it's all processed, it arrives at the subscriber, who does something with it, like updating your screen. And the most important part, this entire pipeline is non-blocking. The whole system keeps on flowing.
But wait, what happens if the source is producing data way faster than the consumer can handle it? Without some kind of flow control, the consumer would just get overwhelmed and crash, right? Well, that's where this crucial idea of back pressure comes in. It's a feedback loop. It lets the subscriber tell the publisher, hey, slow down a bit, or, okay, I've caught up, send more. It's basically the system's safety valve.
Here's a perfect example. Imagine you've got an IoT sensor that's firing off 100 readings every single second. But the database it's writing to can only handle 10 writes per second. Without back pressure, that database would get flooded and the whole system would crash. But with back pressure, the database can signal its limit and the system can react gracefully, maybe by buffering the data or even dropping some if it has to. It's what makes reactive systems so incredibly resilient.
Okay, this all sounds great in theory, but where are people actually using this stuff in the real world? Let's check out a few places where reactive programming is a total game changer.
One of the most obvious fits is for real-time dashboards. We're talking financial trading desks, live sales charts, system monitoring tools, anywhere you need to see data the second it changes. Reactive architectures are just perfect for pushing that information from the source right to the screen in milliseconds, giving users that truly live view of what's going on.
It's also absolutely critical for systems that handle a massive amount of transactions. Think about stock trading platforms or an e-commerce site during Black Friday. They simply cannot afford to slow down. Reactive systems can chew through these high-speed streams of transactions reliably, making sure every trade and every purchase gets processed without a hitch, even under the most extreme load.
And then, of course, you have social media. When a celebrity with, say, 50 million followers posts something, that single event has to get fanned out to update 50 million different feeds, like right now. This is a classic reactive problem. You treat that post as an event that gets propagated out to a massive number of subscribers.
Now, the best part for Java developers is that this whole reactive ecosystem is incredibly mature and ready to go. You've got powerful libraries like Project Reactor and RxJava that give you the building blocks. And then you have full-on frameworks like Spring Webflux, Quarkus, and Vertex that build reactive principles right into their DNA. So this isn't some niche experimental thing, it's a mainstream, fully supported way to build modern apps.
So what's next? Where does reactive programming go from here? Well, it's already pretty well established, but its role in how we build software is only getting bigger. Let's take a quick look at what's on the horizon.
Probably the single biggest question in the Java world right now is about Project Loom. Loom introduces these super lightweight virtual threads to the JVM, which makes handling lots of concurrent tasks much, much easier. So the question is, does this new, simpler approach make the whole reactive model obsolete?
And the answer, pretty much across the board, is a definite no. They're not competitors, they're partners. They actually solve different parts of the same big problem. Think of it this way. Loom's virtual threads make it way easier to handle lots of things at once. But the reactive libraries, they give you that rich, powerful language for working with streams of data, all the operators for transforming data, and, most importantly, that critical back pressure mechanism. The future isn't one or the other. It's using both to get the best of both worlds.
Which brings us to a final thought to leave you with. Whether you think about it this way or not, your systems are already built on data streams. User clicks, API calls, log messages, it's all a stream. So the real question is, are you building your applications to actually listen and respond to those streams reactively? Thinking about that might just change everything about how you build your next project. Thanks for watching The Explainer.